Welcome to this week's Swarf and Chips. We've got a takeover show with TEBIS. We're going to start by finding a little bit more about the company. However, let's start the show with Gerry Cook, who is the UK Area Sales Manager. Welcome to the show, Gerry. Right, I'm going to quiz you. Can you give everybody an overview who's watching? They may know the company, they may not, they may have heard of the brand, an overview of TEBIS here in the UK and as a company as a whole.
Okay, well, TEBIS is one of the largest independent CADCAM companies worldwide. The main office is in Munich, in Germany, and we have 400 employees with offices in all the major manufacturing markets.
And what products are you selling into the industry?
Everything from 2D machining up to 5-axis simultaneous machining. So we do 2D full production machining, 3-axis, 3+2, full simultaneous 5. We have mill-turn modules, wire modules, and also a robotic solution.
And on my travels around Europe, I've seen TEBIS exhibit a lot, and the big emphasis has always been sort of automotive. Is that something that you're concentrating on in the UK?
No, in the UK we're now trying to aim at the aerospace industry and the small, medium enterprises. So a lot of the technology that we've built around the automotive market is transferable across to the aerospace type market.
And within the UK, what is it you've got to offer? Because you've mentioned you've got offices in the UK, you know, staff members, what can you do for those small to medium-sized companies, those blue chip companies within the UK?
Okay, so typically, you know, we've been aimed at the big blue chips, but we've got a dedicated sales and support team, which are all actually engineers by trade. So we actually understand the problem of the customer, and you know, we can provide a solution around that. So we're going to listen to their needs and requirements and build an actual solution and demonstrate that and actually prove it out on their machine tool.
And I think that's really important, because talking to engineers, it's easy to solve the problem. If you don't have that sort of emphasis of engineering background, it's very difficult, isn't it?
Yeah. I mean, we're talking the same language, so you know, it's easy for us to actually create that solution for them.
Now, you've got a quote online that you say, and I really like it, and it says, TEBIS can improve your competitive advantage and increase your profitability. Now, everyone wants that. They want more efficiency, they want to be saving money and making more money. How can TEBIS do this?
Well, we've got a few core packages that we actually work around, which are very cost effective, but we have then a series of modules that we can add on pieces of functionality to make the system correct for the customer. So they don't have to buy a great big package and only use 50% of it. Therefore, we're actually quite cost effective on that front, which is giving us opportunity in the smaller type companies.
Now, to challenge you a bit further here, there's a lot of CAD-CAM packages in the UK, in the world, all very good, but what makes TEBIS unique? What is your USP?
Well, the way that we produce toolpath is different to some of our competition. We actually take into consideration the tooling and the machine tool up front. So we actually produce a toolpath within the actual limits of its environment. So with the rotational limits of the machine head, with the actual size, we're actually creating a toolpath within that environment. And again, collision checking against every single aspect, whether it be fixtures or actually the tables or the heads of the machine.
So you're saying to me then that I've got any machine, you come to my company and say, okay, the limits of that machine, we will work within those boundaries. Is that how you're selling TEBIS to me?
Yes, yeah. So we understand the full kinematics of that machine tool, yeah, the rotational limits, etc., especially on 5-axis. So our toolpaths are automatically created within that envelope.
And how do you do that?
Well, we've got a standard range of machine tools in our virtual machine environment. But if there's something special, something quite different to the run-of-the-mill type machine tools, we can actually come in and actually scan that machine and reverse engineer that machine to build a new virtual machine in our database. So we can do all of the necessary collision checking. So
it's standards and it's specials.
Yep.
Medium, small companies, big blue chip companies, and pretty much you're willing to take on any machine.
Yeah, no problem. Any machine is no problem to us.
So your growth is very much the mid-sized to smaller engineering rather than what you know in the big blue chip automotive sector. That's where you're coming from too.
Yeah, I mean, obviously we're still going to serve our big blue chip companies, but you know, we're now more attractive to the smaller type company with our restructuring of the packages and the modules. It's now actually quite cost effective to actually take a look at TEBIS and see what we can do.
Brilliant. Well, thank you very much. We're going to find out a little bit more about some events and how people can get in touch with TEBIS a little bit later. However, Paul is going to head over to Technical Corner and he's got a little bit of a challenge on his hands.
Phil, we've learned a lot about the business with Gerry there and Lyndsey and Mark on the sofas, but I want to put myself in a position as an engineer that maybe have just bought a new machine tool or has got an existing machine tool, and I'm about to buy a CAD-CAM seat, and I want to find out there's a lot of options for me in the marketplace. I want to find out why TEBIS should be considered.
Well, with TEBIS, because it's an integrated CAD-CAM system, you get the benefits of the CAD, the CAM, and also reverse engineering, as you can see with this component. So the idea being is what we want to do is automate as much as the actual process as we can to make it easier for the end user. So instead of clicking the buttons, we try and actually use templates for starters, or we use feature recognition with CAN cycles that are actually linked to those features to actually, in effect, make one operation. It could be 4 operations in effect, and it will machine and automate the process faster for the end user.
Okay, sort of taking a step back a bit, let's use this as an example, this part here.
Okay.
Let me imagine that I've got this as a contract and this is a new component for me. I've got the machine tool, but now I need the CAD-CAM package to either reverse engineer to make this or to create the program to make this. Why is TEBIS going to be better at this part?
Well, with this particular part, it's because of the TEBIS solution as well. We've done everything from the start to the end. So that means what we've done is we've scanned a hand, one of our colleagues' hands. We've then manipulated the STL to clean the STL and then surfaced the STL to machine.
Tell us what STL is.
So STL is basically triangulated data, which has been pulled in from, it could be Faro, it could be Steinbeckler, for instance. Steinbeckler and Faro, we have a native interface, so you can actually use the arm and the Faro arm to scan directly into TEBIS. We do it with scanning of machines, for instance, virtual machines.
Right, so but once I've done that and this part, I'm going to start to machine this part, how do I know that I'm not going to have a collision?
Well, good point. We have inside TEBIS a fully integrated simulation package, which is integrated to the post-processor. So what we have is, when we simulate, all the movements inside the simulation is connected to the post, fundamentally. So what you see here is what you actually get out of TEBIS. So you don't get any issues with maybe 70% or 80% accurate. We have all the macros, so from one toolpath to the other toolpath, there's actually a macro which is linking those toolpaths. So that means where other packages, they may just go from here to here, let the controller take over, we actually manage the macros, which is fundamentally a key point with our software.
So you're 100% certain then you're not going to have a collision once?
100% sure. We're building these macros. We're building safe positions for the machine tool to go to. We even can take into account the acceleration and deacceleration of the machine. And
how do you know my machine though?
Because what we do is we look at your specification, say for instance for XYZ machines, and we'll take that information and insert that into our virtual machine technology. And that means we can look at the processing time, the look ahead time, the actual acceleration and deacceleration. That's been recommended from the machine tool vendor.
What about, and I notice on this part, you've got an extremely good surface finish here. Is there any elements of your CAD-CAM software that the CAM that generates that?
So normally we tend to get a really good finish with TEBIS, but if you want a more accurate or you want a very fine finish, we have the ability to do point distribution, which will increase the quality of the surface if you need this. But fundamentally, normally what we get out of TEBIS is good enough for a good quality surface finish. But a lot of our mould and die customers are pushing us for perfect finish without any hand finishing.
Okay, do you consider yourself though the TEBIS software as being one of the best at producing surface finishes on parts like this?
So as far as I'm concerned, and I've been with TEBIS for over 5 years, the quality of the surface finish that we get is outstanding, and our strength is the surface finish of the component that actually comes out of TEBIS. So we try and limit the actual hand finishing requirements for harder materials or even softer materials.
Two other things, well, let's start. One of the other points that I'm interested in is things like tool wear, because as an engineer, I'm also looking to make sure that I'm getting the best out of my tool life. How does your software help with that? Yeah,
so inside TEBIS we have what we class as the manufacturing technology, and with that what we get is an accurate tool library. inside your tool library, it could be a tool that's an angle head, it could be a turning tool, it could even be a high performance tool. So what we actually generate a true representation of that actual profile. So what we actually do when we produce a toolpath, it's actually accurate, and you're not actually sort of guessing in effect. You actually get a true toolpath, a clean toolpath. And with all this, we get a better finish in effect, and we don't leave material on for the next tool. So we don't damage
and you get
the tool.
better tool life.
We get a better tool life as well.
The programming side is important. That would be my next point. I'd be looking at how easy is the software to use. You know, have you got canned cycles that I can quickly? What are the strategies like within the software?
So we have strategies from 2.5D all the way up to 5-axis. We even have robot solutions as well. But if you want to break it down into how easy the software to use, basically what we do, or what we do for customers, is we have one, we can have feature technology, which is basically pocket slots or 3D elements, and we can produce canned cycles linked to these feature technology. So this will, in effect, once we've built the library and we've been actually connected the features and the canned cycles, so a drilling operation or a tapping operation, it makes life a lot easier and a lot more automated for the end user. We even then go to the next level, which we call it auto mill, which is 70% automated, which is basically we can pull them apart, we can actually tell it to look at a layer, and we can actually tell it to look at a colour on that layer for that surface. And then we can have templates that are inside TEBIS to rough, re-rough, semi-finish and finish the actual component. So the days have gone where you would normally click, 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 click to get a toolpath. We want to make it as easy as possible for the end user. And
how long would it take me to learn?
So
I know you've got different modules, and it depends on what you're doing. Anything from simple machining up to your 5-axis simultaneous. But how long is it going to take me to get familiar?
We normally do a course for CADCAM for 5 days, and that's for the end user to go at minimum 3+2, where the end user can do CAD, you can do some analysing of the CAD, so you might want to check for radiuses, you might want to check for undercuts, for instance, ready for a manufacturing process, and then also to understand how to build his tool library and how to actually produce the toolpaths ready to then program the part. So normally 5 days is fine.
Moving on to this part here, part 2, Phil.
Okay.
Now this is a classic turn mill component. There's a lot of features on here, pretty complex part out of a fairly difficult material by the feel of it, and by the look of it. There are lots of good quality CAD-CAM systems on the marketplace. I've just won this, I need to program it. Why TEBIS? What's better? Good
question. I mean, with TEBIS, as I've said, we have the CAM package and we have the turning package. So if you can mill 3+2, the functionality and the settings are very similar when you're turning. So you can migrate from the milling to the turning without that much training, to be honest. So it's very similar. The icons are very similar. The functions are very similar. The strategies, as you know, they're going to be different, but the buttons are in the same position. So it's very easy to go from milling to turning, and with the functionality with TEBIS, we collision check everything with the tools, the material trackings inside, and also the virtual technology, which is helping us to understand where the part is and collision checking the whole component with the fixtures, with the moving parts of the machine. So with all that working in harmony and together, it makes the programmer's life a lot easier. So that's one of the main reasons why I would say TEBIS is better and better compared to other solutions.
But if I look at something like that, what am I talking to be able to program with TEBIS? To
program that from the start, I would say maybe a few hours. So once you've built the tool catalogue and the libraries, and you've got the machine set up with the post-processor, it's just a matter of understanding how you want to machine it, what strategies you want to use, milling or turning or roughing or finishing, and actually apply it to those actual that actual component, and then the end result is to output the code.
We have touched on reverse engineering earlier as well, but that's a part of TEBIS that you've kind of pushed heavily today as well, isn't it?
So reverse engineering, as I've been saying, it's one package for everything. So that could be CAD-CAM reverse engineering with simulation as well. So we have a very strong reverse engineering package. So the ability to scan components, manipulate the STL, and also surface it. And also we have the ability to morph data as well for compensation, for example.
And looking at CAD and CAM, where is TEBIS with this? Is it your own CAD and your own CAM? What's the relationship?
Yeah. I mean, TEBIS has been going over 30 years. All our solutions are developed in-house. So in Munich, we have developers that are constantly developing the software. Normally get 2 releases per year. So the answer is basically all our software is developed in-house, so we can always tweak it and change it and develop it to make it even better to actually give it to the end user.
I've got a couple of points here as well that I'd like to mention that I've picked up from looking at your website. Accurate tool libraries, what do you mean by this, and why is that advantageous in comparison to maybe others? Yeah,
good question. I mean, because we want to collision check everything in a virtual world, we want to make sure that everything is designed and built up in our system. So it helps us program from the start, because what we're trying to do is build the tool library to a perfect representation. So even the cutting edge we put inside TEBIS, to the holder, to even feeds and speeds, depth of cut inside the actual machine, or sorry, the tool library. So what we're trying to do is from the start build all of the technology inside with the feeds and speeds, depth of cut, so we don't have to do that when you program. All we have to do is pick a material type. So it could be graphite, it could be stainless steel. You pick your material types, and basically TEBIS will then give you a feed and speed, which is calculated on maths, and will give you an accurate depth of cut as well, and you can calculate from there.
And how hard do you work as a business to keep on top of that? Because tooling changes, materials change.
Yeah, so we're constantly working with tooling engineers and constantly working with our partners to actually understand what the best tools out on the market. So we've got adaptive roughing techniques, we've got high performance cutting techniques. So all this is working with partners outside and understanding what they're doing to actually so we can put it inside our software. So for instance, adaptive roughing has been in the market for quite a long time. We're also looking at high performance tools, barrel cutters for instance, where we can actually, instead of going down a wall and you're actually doing maybe 0.5 depth of cut with a 5-axis toolpath, we can actually do 4 mm depth of cut, for instance, on a barrel tool, where you're actually going down and you're producing the part quicker for the customer.
Another point here that I've got is 5-axis feature recognition with CAN cycles. Now, we have spoken about CAN cycles already, but it seems to be a big part of what you're trying to promote.
Yeah, definitely. We call it inside TEBIS auto mill. So this indicates basically what we do is we build a library of features, and then what we do is we link those features to manufacturing techniques or CAN cycles, as you say. So the idea being is we will build up a number of libraries with variable settings.
And give me an idea of what a CAN cycle might be.
So a CAN cycle could be a centre drill tap, for instance. So it could be we want to have a pocket and we're going to machine it from a solid billet, and we're going to basically rough it, finish it out, and then chamfer it afterwards. So it could be 3 operations, it could be actual 6 operations.
And what if I wanted to put those 2 CAN cycles together? How easy is that?
It's just a matter of linking them. It's that simple. What they actually inside TEBIS, they are variable. So that means the actual system can go and select a tool itself, or you can have it fixed. So with the features, it has the ability to manufacture the part quicker than you would do it manually.
You say it has the ability to select a tool itself. So I've got a tool magazine, I've got 40 tools in there, and the software is going to be able to predict or pick the best tool for the job, correct?
Yeah, on variables, on settings. So basically
what's it going to look at?
So what it will do, it'll look at the feature size for starts, and it will look at the radiuses and the actual chamfer, and it will go away, look at what's actually available in the tool library, and pick the tool that will fit that pocket or hole.
So we're seriously de-skilling the machining process here.
Definitely, yeah. So we're trying to make it as fast as possible to get the part from a billet to a finished article on the actual inspection table.
Without an individual having to go through all the possibility of maybe making mistakes or yeah, like we said, getting it wrong.
Definitely. So we're trying to actually input all the technology inside TEBIS. So we're trying to give it the strategy, we're trying to give it the tools, we're trying to give it the machine, the feeds and speeds, even the actual magazines. Inside the machines, we will have a number of magazines for any type of machine. So instead of going tool 1, tool 2, tool 3, it's already done for you. You just basically link the machine tool library to the actual tool table, and it will output correctly.
So I want to move on here, Phil, to something we've highlighted here as swarf machining. And one of the things is your 5-axis trimming. This is obviously a classic automotive part, but tell us about why you're so good at that.
So yeah, I mean, we've developed bespoke software for trimming from day one. It's not our standard 5-axis milling package, it's a separate module. So it gives you the ability to produce a toolpath and also modify the toolpath on the fly. So this for trimmers is fundamentally important, because a lot of the time the head is in the way, or the vectors. If you get CAD in and the data is not so good, what we can do is we can clean the toolpath up live, ready to go on the machine. And what the beauty about this is, what comes with the basic software is collision checking against the head and the spindle, the collet and the holder
But trimming is essentially just around the outside of the component, correct?
It is indeed, but
glorified deburring.
Yeah, it is indeed, but unfortunately you get a lot of unwinds with conventional sort of milling strategies. And when you unwind and you come back onto the job, you have a witness. And basically with our software, we're planning from the start to the end to get an accurate toolpath. So if you've got a limit of 180 degrees, well, we're not going to get round it in one operation. So we have to understand that we're going to start from one point to the other point without an unwind.
And I know this is a big part of your business. It's something that you are very well known for. Yeah. And then to finalise, we've got 5-axis laser, and we've got some of the areas here that we've already spoken about the mill turn, the turn mill, but robotics, 7-axis machining, polishing, laser, welding, undercut machining. Finish off with those.
So yeah, with the robotics, it's been in the module for just over 2 years now. It's constantly being developed. It's one of the key aspects that we're pushing at the moment, robotics. So this gives you the ability to, any milling operation we can use with a robotic solution. So as in the turning, it's exactly the same, the toolpath is exactly the same. You just apply the actual robotic solution and understand what the singularities are within that robot. So it could be Kuko, it could be Kawasaki. But fundamentally we build in, once again, the virtual machine technology inside the robot with the limits and understand how we use that robot to program or polish or weld the actual component.
I started this session here, Technology Corner, talking about the fact that if I was a small subcontract engineer, maybe with just a 3-axis machining centre and a CNC lathe, I can get the benefit of TEBIS' software, can't I? But you've just then been talking about automation, 7-axis robotics. You go from one end to the other, correct?
Definitely. So we go from one scale to the other, but it doesn't matter what you're doing in the actual industry. If it's a small business or a large business or an OEM, we can cater for that. So if you're trimming or milling or turning or even using robots, TEBIS can actually do the job for you. So
it's going to make you more efficient, it's going to get those parts off of the machine faster, and it's going to be easy to do as well.
Definitely. So with the templates and the automation, this is the whole idea, is to make it as fast as possible for the actual user to get parts off their machine.
So looking at the fact that there is a lot of options here with your software, depending on what sort of manufacturer you are, is it competitively priced for all?
Yeah, I believe so. I think you'll be amazed with what you'll get for the money. So yeah, I think at the moment with the new modules, it's fine. It's good for you.
Good stuff. Thank you very much, Phil.
Yeah, thank you.
Back to the chairs.
Thanks, Phil and Paul. We are now joined by Jill Brennan, who is the Sales and Marketing Assistant for the UK. Welcome to the show, Jill.
Hello, thank you very much.
I'm going to quiz you about events because I want to know, and I'm sure our viewers want to know, where can we see TEBIS in action?
Okay, well, first of all, at the end of this month, we have our open house. It's our annual event and it's being held in Munich, Germany, which is our headquarters. And then we've also got a number of exhibitions that we're going to be at this year. We're going to be at EMO in September, and then we're also going to be at Interplas with our partner Maca, and also Advanced Engineering in November.
You also partner the CADCAM event, don't you?
We do indeed, and we've been invited again this year to Inspiration Through Innovation. It's the 10th to the 11th of October, and we shall be running 2 live machine tools, well, at least 2 live machine tools, where people can come and see TEBIS in action and what we could do for you.
So in the UK, can I just backtrack a little bit? In the UK, you've got what shows?
We shall be at Interplas in September.
And where's that?
That is at the NEC, and we're partnering Maca there. Yeah. And then Advanced Engineering in November, we're at stand K12, so make sure you come and see us.
Yeah, perfect, brilliant. Now, if I'm a small company, how can I get a product demo? So, you know, we're talking about people going to events, but you know what, sometimes people want a little bit more of a personalised service. How can we get in touch? What can you do for us?
Just give us a call. We'll arrange to come out and see you, you know, come out and find out your requirements, and then we'll arrange for a demonstration. We'll actually take in your product into our system, build toolpath around it, and get it onto the machine tool for you.
And I think that's great, because I think a lot of engineers at the moment, they're flat out, or they seem to be flat out, and obviously looking at new products, capital equipment, the whole thing seems a little bit slow at the moment because they're so busy. You going to them, fantastic.
Yeah, no problem at all. Yeah, we're happy to do it on site for them.
So Jill, how do we get in touch?
Okay, if you head to our website, it's www.tebis.com. All our contact details are on there, and you'll be able to either pick up the phone or drop us an email to find out more.
Okay, we'll put those on the screen as well for you.
Just one last question. Jerry, I'm going to put you on the spot. Okay, because what I've learnt today in today's Swarf and Chips is that TEBIS seems to be a complete CAD-CAM solution providing software. Am I right?
That is correct, yeah. We are a completely integrated CAD-CAM solution, doing all your conventional machines, 2 to 5 axis, but also some of the larger CNC routers for trimming applications, also robotic solutions as well for plastic trimming or pattern making.
And for a company of any size as
For
well.
a company of any size, from a 2-man machine shop up to the large OEMs.
Perfect. Thank you for joining us on the show as well.
Thank you.
We always give everybody a Swarf and Chips mug. So here's one for yourself.
Lovely, thank you very much.
And here's one for yourself as well.
Thank you very much.
And this one. Thank you.
Cheers.
Thanks. Cheers.
Thanks to TEBIS for joining us for the Takeover show.
One thing I'd like to say is that if you don't know about CAD-CAM, you do now. TEBIS, fantastic.
Right, and we're going to end the show together.
Okay, what do you want me to say?
Right. If you want to watch any previous episodes, click on the links here.
And there.
Don't forget to like, comment and subscribe. And as we always say,
keep those spindles turning.
That was awful.
That's what I want.